Hello, my name is Sean Murphy and welcome to my Lab 3 video report. Let's get started. A quick overview: the main objective of this lab was to determine the performance curve of a fan and the system curves for a duct with various screens installed. Next, I evaluated the pressure loss associated with flow through a screen based on the screen mesh density. I then compared the experimental loss coefficient and phi values with values given in the ASHRAE handbook. And in the end, the fan performance, loss coefficient, and phi data I had calculated were very close to the ASHRAE values that we were given after I converted them to Laramie conditions, and they differed by less than 10%. The data we were provided with for this lab included the static pressure at the exit of the pump, the pressure drop across the screen, the outlet dynamic pressure, and the probe positions, duct dimensions, and atmospheric conditions. We were provided with data from 3 trials for all of these. The screen properties were calculated using equations 1 and 2, which used the provided data as well as the data that we obtained using ImageJ from the pictures of the different screens. And next, using Bernoulli's equation, the fluid velocity was calculated using the dynamic pressure measured at the outlet. At the end, analytical uncertainty analysis was performed on the loss coefficient, the flow rate, and the change in pressure over the screen using a 95% confidence interval. Onto the results. Table 1 displays the screen analysis results achieved using ImageJ to measure the properties of the screens shown in Figure 2. The ASHRAE data was converted to Laramie conditions, which is what you see here, from standard conditions using a dimensionless approach that we used in the pre-lab. And as you can see from the data, they both have a similar relation. Your loss coefficient increases as your phi value decreases, and their corresponding values are very close to each other. A clear comparison of these two sets of data can be seen on the next slide. Table 2 displays the experimental data obtained in the lab. And as you can see, the loss coefficients increase as the screen mesh density increases as well, which is what we would expect. It's also important to mention that the larger the screen density, the lower the relative percent uncertainty for the loss coefficient in the delta P. So based on this, it's safe to say that the higher the screen density you're using, the lower the relative percent uncertainty you will have. So this may give you more accurate or more precise results if you're using higher screen density screens in your applications. Onto the plots. Figure 3 displays the different system curves produced by the various screens, as well as the fan performance curves. As you can see, the lines sweeping up to the right are our system curves for the different screen configurations, and the lines sweeping kind of down to the right are our fan performance curves. The experimental fan performance curve and the curve obtained from manufacturer data are relatively close. The experimental sits just below it, and so all of the operating points are where these lines intersect, which are relatively close based on the experimental and manufacturer, but the experimental are slightly below. Figure 3 also displays the necessary power usage to achieve all of these different system curves. The discrepancies between the experimental and manufacturer system curves could be due to a few different things, which includes the elevation effects on the fan motor. It could also be that the experiment was done using a worn fan, and it could also be due to imperfections in our approximation of the entire system itself. We could have loss in pressure due to other imperfections that we aren't accounting for. In the end, though, this experiment produced accurate system curves based on the manufacturer data. Figure 4 shows a comparison between the experimental screen properties and the ASHRAE property values. Both these sets of data follow a very similar trend, but similar as in Figure 3, the experimental data sits just below the data obtained from ASHRAE. Some of these discrepancies between these two data sets is likely due to how I measured the different dimensions in ImageJ. A slight over or under approximation of one of those dimensions can have a big impact on the values you see in this curve. So that is likely where some of those discrepancies come into play. But similarly as before, this method also produced a fairly accurate representation of the loss coefficient and v-values. Thank you, and have a good rest of your day.